Hi everybody. So in this video, I'm going to show you how to multiply and divide with complex numbers in modulus argument form. We covered in a previous video these relationships when you multiply two complex numbers. What this is telling you is that the modulus of a product of two complex numbers, z1 and z2, is exactly the same as the modulus of z1 multiplied by the modulus of z2. And the argument of a product of two complex numbers is the same as the argument of z1 plus the argument of z2. And if this is true when you multiply the complex numbers, when you divide, the modulus will be z1, the modulus of z1 divided by the modulus of z2, and the argument will be the argument of z1 minus the argument of z2. So if you're not sure about any of this, you should check out my previous video where I prove these properties for you. Okay, so if we look at example A, we've been asked to write the product of these two complex numbers in modulus argument form. So if we say that this will be z1 and this complex number will be z2, and we want to work out z1 multiplied by z2. So this will have a modulus, and the modulus of this product will be the modulus of z1 multiplied by the modulus of z2. The modulus of z1 we know is 2. Modulus of z2 we know is root 3. So the modulus of the product will be 2 root 3. And the argument of z1, z2 will be the same as the argument of z1 plus the argument of z2. Well, the argument of z1 is pi over 3. The argument of z2 is pi over 4. So when you add these two together, we get 7 pi over 12. So now we can write the modulus argument form of this product. z1, z2 will equal modulus 2 root 3 multiplied by the cos of the argument, 7 pi over 12, plus I sine of the argument, 7 pi over 12. And then we'll close that bracket. So this will be the product of z1 and z2 in modulus argument form. Okay, so for part B, if we look at this division, we want to work out the modulus of z1 divided by z2. This will be the modulus of z1 divided by the modulus of z2. Well, this will be the 8 divided by the 4. So this will be 2. And the argument of z1 over z2 will be the argument of z1 minus the argument of z2. So this will be 2 pi over 3 minus negative 3 pi over 4. These two negatives will make a positive. So when you add 2 pi over 3 to 3 pi over 4, we get 17 pi over 12. But we know when we look at the modulus argument form of complex numbers, the argument has to be less than pi or greater than negative pi. And this 17 pi over 12 falls outside of that range. So we need to know how to fix this within this range. If we were to draw an Argand diagram quickly, your real axis, your imaginary axis, and with the argument 17 pi over 12, well, this will be 12 pi over 12 plus 5 pi over 12. We know this will simplify to make pi plus 5 pi over 12. So this pi will go from the real axis to here, then we'll add on another 5 pi over 12, which will take us to about here. So this will be this argument on this Argand diagram. But to put it in this range, well, because it goes beyond pi, we need to look at going anti-clockwise from the real axis. So we know this will be negative pi, Then we're adding back on this 5 pi over 12. So this argument on this angle will be negative pi plus 5 pi over 12. That'll be negative 7 pi over 12. And this does fall within this range. So the complex number then, Z1 divided by Z2, will be the modulus of 2 multiplied by the cos of the argument negative 7 pi over 12 plus I sine of that same argument. Okay? So I hope that's given you an idea on how to multiply and divide with complex numbers in modulus argument form. Thanks very much for watching. If you found that helpful, you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.